Hello, everyone. Welcome to TAF 2021. My name is Vaibhav Gedigeri, and I am a data scientist working for TIPCO Data Science team. I have with me my colleague, Colin Gray, who's also a part of the data science team. So today we will be walking through a journey of how a data scientist would build a predictive model using Python, using regular IDEs on your local system, and how citizen data scientists and business leaders can seamlessly integrate common data science techniques inside TIPCO Spotfire. So to achieve this, we will show an example of how we can use Python, which is an industry standard language, inside Spotfire using the data function feature. To do this, we will analyze a data set. In our case, we will be looking at a power plant data and estimate, predict a key metric, which in our case would be a production capacity. To achieve this, we will use techniques like correlation analysis, random forest, and feature importance to build an analytical dashboard that can be used by any business user. So watch the rest of the demo to learn how you could go from traditional Jupyter way of working with Python to a fully interactive visual-driven process. So here I have with me a small piece of Python code, which is written in Jupyter Notebook. And you can see here, this is basically a piece of code that computes the correlation between the columns in the data set, something that we would want to do before fitting a model. So here we can see that I have used correlation and plotted the correlation heat map. In this case, we are kind of looking at the correlation by using the Pearson's method. And if we go down, you can see that this is kind of done by changing the method. In this case, this is the Kendall coefficient. Colin, how would one take this Python or R code and integrate this into Spotfire?
Yeah, so it's a really good example because in this case where you've got your Jupyter, you've put the code in to produce a couple of plots, but you're having to alter code, and it's a nice way to develop and work, but it's not as easy to really drill into the data. So what we can do is pull that into Spotfire and then try and get the best of interactivity with the power of the code that you've developed in Jupyter. We saw the code that you had in Jupyter, and that code, is a nice simple correlation function. You did this really nice plot, all run it through Jupyter's interface. The nice thing about bringing Jupyter to Spotfire is you can copy the code that you have, you can see here, and you can put it into what's called a Spotfire data function, and you can paste in that code as is. The only real difference between running Spotfire Python through Spotfire versus through Jupyter is that the inputs into the Python scripts, so when you're reading your data in, when you're setting, for instance, the method to Pearson, we can pass that in from Spotfire to Python. So the two communicate seamlessly, allowing you to run the code repeatedly without having to alter the code like you would in a normal Jupyter environment. But let me just demonstrate how this works when you add it into Spotfire, and then demonstrate how good you can then expand upon that. So here we have our Spotfire interface, and we'll go through this example in more detail later. But what we have is we've got this nice data function flyout, and this shows all the data functions that have been deployed in Spotfire. So if we want to add it into our analysis, all we have to do is simply click on it. Now I'm seeing my data function, and it's showing me a nice interface here that I can actually configure the data function. This is the same as when you were doing it in Jupyter and you were reading in, say, a CSV file and specifying in the code. But what we do here is we can actually join it and connect it to data in Spotfire. And this makes it very dynamic and powerful because you can connect it to any data source, files, databases, or any source that Spotfire can talk to. So in this case, we've got our plant anomalies, and we're going to select certain columns we want to pass, and it all works in this very simple interface. We can then specify the method. Now in code, we had put in Pearson, but we can connect it to a property in Spotfire, and that allows us to make it dynamic because we can change that property without altering the code. So I haven't touched code at all, but I'm calling that same Python code exactly as we did through Jupyter. So now it's running, it's completed, and what it's saying is We've got a new data table, so let's add it as a new data table into our Spotfire analysis. And you can see here that we can now drag on a very simple table and look at the column correlation results between all our columns and all our data. And this is the same data exactly that Jupyter presented.
What I see there, Colin, was the data frame that that was the output of the Jupyter, and I see that show up here in Spotfire. But my question really would be, why Spotfire when I can write all this code in Python and Jupyter Notebook or any of the IDEs, and basically visualize using some of the libraries like matplotlib or Seaborn, like how I was showing.
Yeah, no, and it's a fair point that we're all often taught and often used to using code. It's very free to quickly develop code, but code is difficult and hard to maintain and productionize. So there's not many reasons you might do this. Putting an interactive visual tool on top of your code means it's much more accessible. You can now spread it across the whole of your business for other people to use who don't have coding skills or don't have the tools to run the code. That's one big reason. So it means your work as a data scientist or an analyst has a much bigger impact, and your work is spread out much more across the business to more users. For a business user, it's great because they get the power of these techniques without worrying about how to develop the code. They just need to know how to apply it to the use cases that matter to them. Then you can integrate it in your analytics as well. For the managers or for the business as a whole, it's really important because it gives you a much more sustainable way of working with data science. It's much more robust because you're not altering code all the time to just do simple changes like explore different options on your data. It means your data scientists can concentrate on the code while your business users can concentrate on using the data science that's been exposed. It makes it more maintainable as well because different people's skills are used better. So you're, from a business point of view, it's really powerful that you can see the impact of all these analytics without the complexity that runs behind it. This is one way of visualizing that data. You see the heat map, which is very similar to what we saw in Jupyter. So you get a nice simple thing, but you already notice that you get tooltips as you hover over, but we can do lots of visuals, and this layout is just one I've picked. But here we can see, for instance, all the different correlation scores. But what I've got here is this nice network chart where I can actually explore and see all these networks. And this is done using Spotfire mods, which is a new thing that's been added in Spotfire 11, where you can design your own visuals through JavaScript libraries. So for instance, if we want to change the type of correlation, we can just change a simple dropdown, no code involved. This then passes it out to Python. So if I click calculate, it's now running the Python code again. And what you'll see is that these values will change and all update live for you. So it makes this very interactive. You can now see I've got quite a different network from using a different correlation technique. And we can also do nice things like filter. So Spotfire gives you these interactive filters, and you can see all the charts change. And now we can see and explore these different relationships in that network, showing what's strongly related and what's not. So this was an example of doing correlation analysis through Spotfire using Python. And the data function that I've shown here is available for download for anyone to use. Just go to our community exchange, which is at community.tibco.com/exchange. Now we'll do some analysis and move on to a more complex use case where we'll build a predictive model using Python, again through Spotfire. For example, here we see where we've analyzed the production of the plant using time series data. We've used time series and other visuals to analyze the sensors, the profile of those sensors, and really learn about what was recorded at the time through, for instance, free text analytics of logs. Now we've got this knowledge, we want to move on to building that predictive model. So what I've done is I've built another screen here that, again, any business user could use. Even though it's doing some advanced data science tasks, we can present as little or as much as we want to the end user, so it's a simpler process. When you click Build Model, it's now sending that data to our random forest Python data function. It's sending all the data, filtering to just those columns, telling Python only to use these settings for the random forest, and now it returns all the results to Spotfire. So we've got a nice model using machine learning through Python. So this allows us to now use that model we built in Python to actually simulate the impact upon production. So imagine we want to set a new limit of the gas level to 5. We can see what would the impact be, and it's going to use that data, alter it and send it to Python, and use the model we previously built to show the impact it has. And here we can see in the pink line the predicted output based upon the Python model we built previously. And this shows a nice improvement in the production overall in this case. In this example, I've shown how you can do visually driven data science using Python with Spotfire. Two of the key components of this was the correlation data function and the random forest machine learning data function. Both of these you can actually download from our typical community exchange and a whole suite of other R and Python data functions. If you want to see a list of these, you can search Google for Spotfire data function library and it will find this page. And here we've got a great list of data functions available, geoanalytics, machine learning, etc., where you can download and read about them. The other route you can go is to go directly to the typical community exchange, and you can tag data functions, and it will list all the data functions available for download. You'll see here the column correlation that I showed at the start, and also the random forest Python data function that we showed at the end. So please go ahead and download these or write your own data functions and get started with data science with Spotfire.